Welcome everyone to our session on From Black Swans to Boiling Frogs, How to Understand Risk and Build Agency for Early Action. My name is Shana McLean and I work for NASA's Earth Sciences Division, but I'm joined by three really dynamic and interesting female colleagues, Yolanda Lin from the University of New Mexico, Emma Flaherty with the Risk Informed Early Action Partnership, and Shana Skolnick from Navteca. We're going to essentially talk to you today about the different ways that we understand and perceive risk and the roles and responsibilities we have in better understanding them and building agency for earlier and improved action. Yolanda had created this event or this page on the Risk Zoo, and so I'm using it here just to welcome you all to this discussion, and you'll learn a little bit more about this as we proceed, but just to say, essentially we are talking about the fact that there are different impacts, different consequences, and different probabilities involved when we talk about risk. And but the way that we look at it informs how we also prepare or respond to these. And this is something that we're trying to get better at with this session and the discussions we intend to have. So in this case, I'm going to just fly through a couple of examples before we get specifically to our speakers. But in the last several years alone, we're hitting a number of records with the way that different hydrometeorological events are occurring. Of course, in 2017 in the Atlantic, we had a series of disastrous impacts: Harvey, Irma, Maria, Nate, all so destructive that their names have been retired and are in fact synonymous now with the type of destruction that comes with these events. Last year in 2018 and 2019, the cyclone season for the Southwest Indian Ocean region was the costliest and the most active season on record for this region. And this is essentially talking not just about Idai and Kenneth, which we're all very well aware of, but also Fani as well, just the different types of absolute devastation that they cause. And then finally, it leads us now to where we are in 2020, which has hit a number of other records with being the most active hurricane season on record. But what I think is most important about this is the fact that it's also the 6th year of pre-season systems. And so we're talking about issues where we're asking or at least thinking about events as though they are high impact but low probability, when in fact they are more and more high probability events. And that also what we've known or come to know as particular seasonality of events is starting to shift with climate change as well. And so how we can start to unpack our understanding of these changes, what it means for how we can visualize these changes and then lead to action, is the focus of our talk today. And so with this, I'm going to start our first presentation with Yolanda Lin, who's going to talk about counterfactual thinking and risk perceptions. So Yolanda, over to you.
Thanks so much, Shana. Let me just get my screen shared and started. Okay, hopefully, can you guys see my screen okay?
Perfect.
Okay, awesome, thank you. So yeah, I'm gonna be talking about counterfactual thinking and perceptions of risk. So in terms of, the title of this session, really focusing on the how to understand risk portion and how we, and really focus on how our descriptions of risk can actually exacerbate risks in some cases. So Shana, introduced some of those events, and in particular, she mentioned Idai and Kenneth, and the question is, was that back-to-back events? could they be considered black swans? And the answer is it depends, and here is why. So first I want to go over what a black swan is. So it's an event that is technically defined as something that has a major effect that is rare, and importantly is a surprise to the observer. So my point here is that if we do know about it, if it's not a surprise, we really shouldn't be calling it a black swan. And of course, no one can predict exact events in time and place, but I'm talking about the possibility of such a hazard of calling it rare when in fact it's no longer rare. And furthermore, the use of this term really robs us of the agency to take action against such events, because a black swan implies that there's nothing we could have done about it ahead of time. If you don't know about it, how could you prepare for it? So we need another name for these events that might still have a major effect and are, not super common, but not totally rare. So here we want to introduce the black elephant. So it's a cross between the black swan and the elephant in the room. So something that's still rare, still very impactful, but we do know about it, and it's difficult to address, so we don't necessarily want to talk about it. And as Shane introduced earlier, there's actually a whole range of animal kingdom metaphors that we could be using that would be more appropriate than the term black swan. And importantly, these terms allow us to acknowledge our agency in early action and preparedness. So I'm just going to do a quick introduction to the Risk Zoo. This is a collection of risk-related animal kingdom metaphors that I created recently. And so far there's 16 of them. If you know of any that are not on this list, I would love to hear from you. But basically along the vertical axes, we have consequence mapped, and then we have probability mapped from left to right. So you can see the black swan is all the way up here in the corner. And then other things are encoded on the map as well, like the onset times. So you can see with the boiling frog, it's very slow onset, as well as visibility. So in this zoo, you'll notice that there are indeed, before I get to that, you can find the whole zoo with all of the descriptions of each of these metaphors and additional sources for reading at this link down here, and this QR code should work. And this was actually made as part of the Dat Artathon workshop. Which you can learn more about in about 9. Some metaphors and animals that focus on the fact that there are a bunch of other still consequential kind of animals out there, and they're made consequential not because they're rare or difficult to spot, but because we have applied a sort of willful blindness to them, such as the black elephant that I introduced earlier. So one tool we have to address this is the use of downward counterfactual thinking as a way to combat this bias. So what is downward counterfactual thinking? Luckily, we have all engaged in counterfactual thinking before. It's the act of asking what if about a past event. We tend to, as people, think in the upward direction. So we try to make the past better. What if we had been more prepared? But what I'm offering is the invitation to think in a downward direction. So if it had been worse. And this latter type of thinking is generally not the most intuitive. And so generally to apply this, we start with past real events. So either using what I like to call invisible events, so hazards that had occurred but maybe didn't incur much impact due to low exposure or some other reasons, or past disasters, past events that we consider disasters. We start in the place of reality for the context and the texture and the familiarity, which all lend to the believability of a potential scenario. So then we apply downward counterfactual changes, such as a change in time or a location, or other factors. And in the end, we can uncover an event that was worse than what actually happened in the past. But it shares almost all of the same context and familiarity as that past event. So this hopefully enables additional lessons learned and preparedness without having to experience every single version of a disaster. So again, we're trying to build a case for mitigation without having to experience types of disasters that we maybe consider unlikely or we don't think will happen here. So this is just a summary of what the framework is like. So we're starting with some sort of past event. Here's a cockroach. We apply some changes and we get to a different type of animal because of the downward counterfactual changes that we applied. And we actually just published this framework and some of the case studies along with it, and you can find that online here at this link. So this is just one tool to help overcome this kind of willful blindness bias, to hopefully enact change and enable us to address risks and hazards that we know of. So we're not talking about the unknown unknowns anymore. We're talking about the hazards that definitely exist, but that we pretend don't exist. So back to our question of were these back-to-back cyclones black swan? And it really shouldn't be. And I say that because how we describe risk matters for public perception of these hazards. Again, if we call it a black swan, it implies that we couldn't have done anything about it. But of course, it is a matter of perception. So, one event could be a black swan to someone if they didn't have any idea. But as part of the sort of DRR community, we should not be calling this a black swan. So again, just kind of more evidence on why consecutive storms are not black swans. We had 2 storms recently hit Manila, pretty much back to back, as well as 2 near misses for New Orleans. And that's really a prime candidate for downward counterfactual thinking. What if this had not been a near miss? So the question is, do we need to experience every version of a disaster for that specific hazard in that specific location? Or build for mitigation and highlight our known and not. Look forward to the panel discussion. And Sheena, I'll hand it back over to you.
Thanks, Yolanda. That was great. We'll take, please, as we move forward, do feel free to add questions to the chat as we will get through the next 2 presentations, and then we're going to open it up for discussion. So we definitely do want to hear from you. We'll just address the questions after the next 2 presentations. So thanks, Yolanda. I have to say, I didn't realize that there was a risk associated with cockroaches before, other than my fear of them. So it's been fascinating to learn about how to build context and give greater focus to some of the events that we consider to be quite invisible. Next, we're going to hear from Emma Flaherty, who's going to talk about acting under uncertainty and building agency for change. And so, Emma, we're going to turn it over to you, and I'm going to start sharing the screen.
Be helpful if I unmuted myself. Can everybody hear me okay? I'm going to take that as a yes. So I work with the Risk Informed Early Action Partnership. So as you can imagine, we are very interested in the implications of Yolanda's zoo, and that's what I want to talk about a little bit today within the context of what happened in Mozambique. So to discuss a little bit, when is a black swan really not a black swan? So you heard from Yolanda that a black swan should be it's a surprise to the observer. So would you mind popping to the next slide, please, Shana? So why was Edai not a black swan, even though it might have been conceptualized as one? I think if we look a little bit, first of all, I think we need to talk about the context in which these 2 cyclones occurred in Mozambique. the climate context and the development context that they occurred in. So Mozambique is in southern Africa, where temperatures have been rising at twice the global rate as a result of the climate crisis, and there's been multiple shocks in the 12 months leading up to the two cyclones. The UN estimate that nearly 17 million people across the region face severe food insecurity because of cyclones, because of floods, because of droughts, and that's chronic food insecurity. And in Mozambique, which we're going to focus on now, they estimate that about 2 million people face difficulties in accessing very basic food needs. So food insecurity sits at 24%, 42% of children are stunted. So the emergency thresholds for that are normally around 10 to 15%. So that's the context that this swan, black, white swan, or whatever we want to define it, whatever we decide we will eventually define it as, happened within. So a case of chronic food insecurity, chronic vulnerability that's only been exacerbated by climate crisis. Looking back or reflecting back on a black swan being a surprise to the observer, EDI was not a surprise. I want to use some information from my colleagues and REAP members, the World Met Office, World Meteorological Organization and the UK Met Office, to just flag a few different timelines at which early action could have been taken to stop this event turning into a massive humanitarian crisis. Because I think while we obviously can say that event is not quite a black swan if it is a surprise to the observer, and it certainly doesn't need to be a black swan or one of the scarier animals in the zoo, regardless of how big or severe the hazard is, if we're watching the warnings as they're coming along and taking the necessary early actions. So EDI started to develop on the 4th of March, close to the coastline, as a tropical depression with wind speeds of 55 to 75 kilometers, so nothing too crazy. During the following 4 days, and we just want to illustrate how EDI kind of hung around and menaced Mozambique before it hit. So during the following 4 days, low pressure persisted before it turned back southeastward early on the 7th of March, getting very close to the Mozambique and Malawi border. From the 6th to 8th of March, there's persistent and heavy rainfall associated with it. So river basins and reservoirs are starting to reach capacity. It get very dangerously close to capacity. Then on the 9th of March, the remnant low pressure moved back towards the sea to the Mozambique Channel. And that's where it started to rapidly intensify, building into an intense tropical storm with winds going up to 250 kilometers. That's by the 11th of March. And the reason I'm giving you these numbers, the dates and the wind speeds, is to show this is what the science was showing us in the lead up to it. This is what the science was warning us. EDI then started to reverse its track on the 11th, heading back towards the Mozambique coastline. And Met Office experts say on the 12th of March, the uncertainty of the forecast had massively reduced, well below the usual standards, and it was clearly indicating that EDI was going to hit Mozambique, particularly in the capital area. Landfall eventually occurred on the evening of the 14th, and the rest is grim history. Winds were at 165 kilometers and gusts of up to 230 kilometers. Torrential rains, very high seas, in some places estimated as waves exceeding 10 meters. So that's a very, very grim picture, but it's a grim picture that was being built at a number of junctures in the lead up to this crisis. Shauna, if you wouldn't mind going to the next slide. So I don't want to focus a huge amount. There's a lot of information out there on the humanitarian impact. So I want to give a little bit of an overview of that, but then look at what could have been done if we had, if all the actors involved had the information, the capacity and the willingness to act under uncertainty. So more than 1,000 people were killed in Mozambique, Malawi and Zimbabwe. 2.6 million people left in desperate need of humanitarian assistance, and actually 2.7 million people needed humanitarian assistance related to EDI 1 year later. So the caseload is not absolute after the hazard hits. And there was wide-scale damage caused by cyclonic winds, coastal flooding due to storm surge and inland flash flooding. 3,000 square kilometers is the conservative estimate of land that was affected by flooding. 715,000 hectares of that was crop fields. Now, bear in mind the stats I shared with you at the start about how food insecure Mozambique is. The rain and winds create an inland ocean on the coastal plains. So that is a health disaster waiting to happen, stagnant waters. And almost half of that land that was left underwater was irrigated croplands, so totally destroyed, crops destroyed. And then another kind of very stark fact about this is that despite massive global efforts and huge efforts by the government of Mozambique also, the humanitarian needs of this response were never more than 50% funded. Humanitarian response is very, very expensive. And that is yet another reason why we want to encourage people and understand how we can facilitate them to act under uncertainty. Now, Shanna, if you wouldn't mind just kind of slowly going through the pictures there, and I will talk a little bit about what could we have done, what could have been done here. The what if, the counterfactual, what if we had acted early? What if the hydromet early warning information had flowed around the different government and non-governmental systems and community systems correctly? The land flooding, that was obviously devastating and has had a huge knock-on effect on the population. Could much have been done about that at that scale with a 3-day forecast or even a 5-day forecast? Maybe not, but maybe some items could have been harvested and wouldn't have been 100% lost, but maybe not. Even better would have been if the considerable and increasing risk to this land caused by cyclones and the increased risk of cyclones due to climate change had been considered in medium and long-term planning, and suitable adjustments could have been made. 1,000 people died. That did not need to happen. Evacuations could have happened. Evacuations, shelters with health and water and sanitation and food facilities could have been established. Critical stocks from the government side, from the non-governmental side, from the private sector could have been moved at any of those junctures, the 10, 5 or 3-day forecast, depending on how critical they were, to prevent damage or entire loss. Some infrastructure strengthening could have been done, both from the start of those initial, say, 10-day forecasts, but also prior to that, if actors were coming together to analyze risk across different spectrums of time and different stakeholders. Shelters could have been strengthened in the immediate lead up, and existing community, non-governmental and governmental DRR response capacity could have been mobilized, they could have been supplied, they could have been ready to respond, because no matter how much preemptive risk analysis you do for a hazard this big, you're still going to have a humanitarian response, but you can have an earlier, more efficient, more effective one, the more that you do before the hazard hits. So again, there was quite a lot that could have been done on those different dates that I mentioned at the start, had there been coordination and information dissemination in place and joint planning, and as well as joint risk analysis around what was coming, what the likelihoods were, particularly when it's based on impact forecasting, where, okay, at 10 days, your cyclone forecast is not really hugely accurate, but if you were able to look at the potential impact and see the kind of numbers that did actually come out of that, you would probably be much more willing as a decision maker to act under uncertainty. It's no surprise, it's no secret that a few weeks after Idai, Kenneth happened, the strongest tropical cyclone to make landfall in Mozambique since modern records began, further devastation. And then a couple of days or weeks after that was cholera, which is, diarrheal disease outbreaks are almost inevitable with these kind of weather and hydromet disasters. It's very, very rare to have a disaster related to storms and flooding and then not have some health and water and sanitation related humanitarian impact. So the cholera was something that the government and other organizations on the ground were better prepared for, not least because of advances that have been made in predicting and modeling cholera, and also very strong institutional knowledge and capacity to respond. So they knew the when, and they knew when to act and how to act, what to do. So they were comfortable to act under a certain amount of uncertainty, particularly as they knew what it would look like if they didn't take definitive action very early. So cholera was responded to in and mitigated faster than happens sometimes in these cases, but it still shows that while we're focusing on black swans or black elephants and all the kind of more impressive large members of the menagerie, other smaller animals are looming. It's very, very rare, as I mentioned, to have a weather-related disaster without the resultant health or Watson crisis. They can be forecasted and acted upon early, perhaps probably with more ease and longer lead-in times. So if we consider them as some of the kind of the quieter and less scary animals within the zoo, we might have more capacity to act early on them. The other aspect is, let's not forget Zimbabwe, Malawi, and other countries in that region. They were also really impacted on this, but a lot of the attention was drawn toward Mozambique just because of the sheer scale of the devastation. In Zimbabwe alone, 270,000 people were affected, 51,000 of them were displaced, more than 340 died, and 1,500 kilometers of the road network was rendered unusable for months. That's a devastating impact on markets and livelihoods. So that further underlines that while we're focusing, as I said, on the big impressive animals in the menagerie, we may very well be missing the enroaching spread of, I don't know, is it cockroaches or red ants or termites or however we want to class them. So these kind of small to medium crises or highly localized crises or under the radar to us in the West crises represent the highest humanitarian caseload globally. And they probably cause just as much disruption and loss to gains made in addressing chronic underdevelopment, be it by governments or community organizations. So it's absolutely crucial that we understand this as we try to get to grips with a world that's more and more vulnerable to climate shocks and stresses, and that we need to understand when is a black swan not really a black swan, but also what are all the other animals in the zoo doing, and are we too focused on the big event? There are more crises, there are more disasters, there's more shocks than ever before, but this also means that there's more opportunity and more responsibility for us to take the risk information we have and act early and act definitively to protect lives, livelihoods, and the very tentative gains made for chronic underdevelopment in many of the most climate vulnerable countries. Thank you.
Excellent, Emma. Thank you so much. I think you make really incredible points. I think one of the ones that really resonates with me is just, and connects partly to what Yolanda was saying, was this idea of the invisible event and how that connects to, you know, the funding and the effort that we give to people or countries that need it when an event occurs, but also this idea of timing, where we're looking at the fact that risk is still present even after we've had a disaster occur. And so just some of these cascading risks that happen after the disaster, we shouldn't just be focused on the movement of a particular hazard, but instead we should be focusing on the elements that allow us to look at you know, health hazards, transportation issues, other things that are preventing us moving forward after the event. With that, I'm going to turn over now to Shayna Skolnick, who will be talking about how to visualize risk and the connections of visualizing risk to the particular actions we can take. Shayna, over to you.
Hi, everybody. It's nice to see you virtually today. I'm Shayna Skolnick. I'm the co-founder and CEO of NAVTECA, and I have had the great pleasure and honor of working with NASA for the last couple of years to really explore some new technology tools of how to visualize risk and how to put together all of this information. So we've seen from the other presentations just how important it is to be able to understand the massive amounts of data that exist in the world, whether it's early prediction, whether it's model output, whether it's Earth observation, satellite data. We have reams of information, but clearly it's not being put to good use, as we have also seen from Emma. So what I'm going to talk about, and hopefully infuse a little bit of hope and optimism, is talking about some of the technology tools that we have been exploring and how they might be used going forward. So this is all research and development, not operational yet, but we have high hopes that this will really make a difference at some point in the future. So let me just share. Okay. All right, so typically we look at the Earth in a very flat way. We're not looking at it dynamically. We see a lot of distortion with the way that the size and shape of the continents is displayed. We don't understand particularly well the way the polar regions are because they look giant when they're spread out across the bottom of the map. We don't understand the relationship of the Pacific Ocean when we look at Mercator projection because we see it as opposite halves instead of actually points that are connected. And so when we talk about data, when we visualize it, we need to look for better ways to understand. The other thing is, again, talking about data numerically is very difficult to understand the impacts. When we talk about a 2-meter level of sea level rise, or when we talk about a 10-meter storm surge, what does that mean? When we talk about 1.5 versus 2 degrees Celsius in terms of global temperature, what does that mean? So being able to visualize this, but visualize it more than just the photo, because when we look at the aftermath, when we look at these types of photos, what we're missing is that numerical data. We can get some sort of ground truth and understanding of what's going on the ground, but we really need to bring both together. So one of the ways that we have been experimenting with doing that is through virtual and augmented reality and gaming engine platforms. Hopefully you've all had some experience with playing a game, whether it's on a computer or on a mobile device, or maybe even with virtual reality. What we are able to do is actually use the underlying platform and bring data, bring Earth observation, bring GIS into this amazing way that we can get practical results and practical applications from the same technology that is being used currently for entertainment purposes. So as we can see from this just little introductory video, with virtual reality, you are wearing a headset. You also have controllers and positional tracking to be able to interact with the data, be able to explore it. Oops. And interact with it in a way that really is unprecedented and different than just looking at it on a screen. So we're going to dive down deeper into this. The other thing is that it's exciting to people. Being able to look at data in this way using gaming and entertainment technology gets them to be to understand it in a way and to relate to it that is totally different. So when we take that, again, technology that's currently being used more for entertainment and really look at it with a practical focus, it can open up a new world of understanding. So I want to give you some examples of that. When we are immersed inside of a gaming engine, we get a really different sense of size and scale. So in the example that you're seeing here, we were able to connect the NASA Disaster Applications Portal, which is a GIS web-based portal, and connect it to our gaming engine virtual reality platform to actually ingest information about specific disaster events into this interactive platform. So now we have a better sense geographically of where we're looking, this satellite view, but we can also go down to the street view. And I think this is one thing that's really compelling, is being able to get that bird's eye satellite view, but then also really zooming down interactively to the street level, to the ground level, because this is where people are impacted. We need to be able to understand building by building, neighborhood by neighborhood, what are the impacts to people's homes and to their livelihoods. These type of technologies can also help us see things that are very difficult to understand, such as air quality. And yes, we can have air quality black swan or large disaster events, such as with Fukushima. So I want to give you an example of what does that mean to go down inside the data. This is an example from Hurricane Maria, where the user is actually able to play with the data set and be able to see, oh, I'm sorry, Hurricane Matthew. I have another example of Hurricane Maria. This is Hurricane Matthew. So we're currently over the Caribbean, and the users are able to interact with the data sets, be able to zoom, be able to navigate the data points, and choose what they want to look at. This is really different than just a video or just photos, where you won't be able to have any kind of interaction or go look at something else. Hey, I saw an anomaly. With the game, look at that and also look at scenarios. Because as Yolanda was explaining, it's very important to be able to understand worst case, not just what happened, but actually looking at different modeling and understand for the future. Because when we look at what happened, for example, in Haiti after, Hurricane Matthew, we can understand it was bad, but we also understand that it could be so much worse. So in this example, we made a model of San Juan, Puerto Rico, using real building footprints, real 3D terrain, and then took model output data based on a model to look at the possible impacts of different category hurricanes. So we know that Hurricane Maria devastated Puerto Rico, and it hit as a Category 4, almost Category 5 storm. Now we can look at it. What if it had been a Category 5 storm? Now I can zoom down, again, down to that ground truth level and really understand what is the flooding at the first floor elevation? How does it impact critical evacuation routes, critical access routes? Is the port flooded? Is the airport flooded? Being able to understand this and understand potentially what the cascading risks would be, how long the water is going to stay, where is it going to pool inland, as Emma was explaining. These are the type of visualizations that we can put together using existing data to potentially give us new understanding for the future. And this is what it's all about, right? Is being able to connect the dots, being able to take this technology that's available to us, bring in geospatial data, all of the critical infrastructure, whether it's buildings, whether it's levees, putting that together with model output, plus the observed and earth data that we have, and then also being able to collaborate. In these COVID times, it's more important than ever that people can look at the same sets of information and be able to discuss them and talk about them. And these types of platforms really encourage and allow for that. Just like these massive multiplayer games are working. Can you imagine this type of a scenario where people all over the world could be collaborating, looking at this interactive way to look at data and making some decisions and increasing their preparedness? And we can use lots of different types of disaster data. So I've showed you flooding. This is an example of earthquake data. Now, in this case, this was a real event, not modeled. This was radar data from the 7.1 earthquake that hit Ridgecrest, California. And so again, when we see that on the real terrain, when we can zoom down and understand the impacts for the population centers, for agriculture, when we get the overall sense of size and scale of the event, it is a different experience than if we are just simply looking at a map. Because this is what's important, right? Is the building by building, street by street data is what we need to make decisions. Well, let's move on to a bigger sort of long-term discussion about a threat, which is sea level rise. And as the others have pointed out, these aren't black swans if we know that they're going to occur. Even when we zoom in to the web-based tool about sea level rise, it doesn't particularly give enough information to take action and increase preparedness. So when we bring that same model output data into the gaming engine platform, into virtual reality, then now, as you'll see when we zoom in, it comes to life. We have three-dimensional buildings. I can see the actual conference center. In this case, we're looking at San Diego in Southern California. Now, when I see that color-coded flooding information overlaid, all of a sudden, I really understand the impacts of those main transportation arteries right next to the water. I understand the impacts to those downtown buildings, to being able to see the stadium and understanding what will that do potentially to commerce and some of the other important economic drivers in the region. So a tool like this now could be used by city planners, mayors, and other types of decision makers, emergency managers, being able to really increase their resiliency to future events, because as we know, they're not really black swans. we know they're going to occur. And so using this type of scenario and model-based thinking and actually being able to visualize it in a real way with great textures, real buildings, actual terrain, then we can start simulating these events before they occur, seeing them before they happen, and therefore preparing for them. You don't have to have a headset to be able to derive benefit from this technology. You can, as you see here, be able to look at it as a video, as photos, be able to understand through color coding which structures are going to be impacted. So there are many ways that the technology can be used even without having necessarily the headset and controllers. And just to show you an example of how good the technology is and how realistic it is, I have a side-by-side of a photo that I took from my airplane seat back when we could travel in Boston, next to the same scene in our gaming engine. You'll see that we have all of the realism needed to be able to make actual decisions once the data is overlaid. Now, looking at that same city of Boston in virtual reality, I want to show you model data for sea level rise. This isn't to scare you, but it is to show that we have information that isn't necessarily being used in an actionable way. Because when I change the water height to just 5 feet, so not good with the conversion, maybe 2.5 meters, I start to see that there are already significant impacts to the downtown inner core of this historic city. When we raise the water level to 5 or 6 meters, we see devastating impact. So we have data today that could help us to better be prepared, whether it's for a hurricane or cyclone, or for the long-term effects of climate change and sea level rise. If we were to use these types of technology effectively, we could be putting our resources and dollars towards better data-driven decisions. A further example is for landslides. A lot of countries are facing severe impacts after high rainfall events. And as Emma mentioned, these aren't necessarily associated with specific named big impact storms, but they do have devastating impacts locally. So this is an example of landslide data from Dominica and being able to see how it comes to life with that 3-dimensional terrain. And again, this is a fly-through video from the gaming engine from inside where you have that 360 3-dimensional view. And even just through being able to see it as this video output, regional decision makers could potentially understand the impacts to those, houses and agricultural communities in a way that would probably be not possible through just looking at it on a flat surface, flat map. Finally, we know that climate change is here. We know it's impacting us. We know that it's happening. We have all of these technology resources at our fingertips. We have amazing amounts of data, and we really cannot afford to ignore it. So this could be an amazing way to synthesize that data through a gaming engine, through virtual and augmented reality. We can really increase our understanding and therefore our resilience if we can visualize and plan, because we know that extreme weather, disasters, and climate change are not black swans. We know that they're going to happen, and we have the tools to be able to make better decisions that will give us a better tomorrow. So with that concludes my little presentation. I'll turn it back over to Shayna, and I think we'll be taking questions.
Excellent. Thanks so much, Shayna. I think there are 2 points that I'd also just like to highlight from the work that you're doing. Technology presents an interesting solution to us in a number of ways. I think in one way that I see very clearly coming from the humanitarian sphere, now working for NASA, is that a lot of this data is really just quite impossible to understand. You show the very colorful images, and for me, I think, oh no, I'm out of my element. But I think the work that you do helps really put things in context, and that's the element that we're talking about here today, is really the understanding the context for these events, and then using the information in a way that can improve our decision making. And then the second element is really, I think, about how we can take what we've learned. We can't go back and erase the events that have happened, but we can look at past models and hindcasts of data in order to better prepare and plan for future events. And so this is something that tends to resonate really well with the planning and development sectors in particular, particularly where we're talking about people that don't necessarily use all of these technologies in their day-to-day decision making. So excellent job. I think at this point, I'll ask Emma, Yolanda, please, I'll turn on your cameras if you aren't already. I'd like to open it up to questions from the audience. So if you do have questions, do please ask them in the group chat. But I'll start off with a couple that have already been posed. And so maybe Yolanda, I know you responded to Renard, but I think it's interesting to talk about, the way that we communicate risk is also about language issues. And so while your risk zoo is in English, do you have any thoughts or comments about essentially what it means to translate some of these things coming from your work in Singapore, for example?
Yeah, well, I think it was a great point to clarify that these are English-based metaphors, and I think I mentioned in the chat box that I would be really interested to know which of these kind of translate across cultures, and which, where we might be able to find other metaphors that aren't in English. And then the other thing that you were asking about in terms of how do we frame this, in context for a place. I think the main thing is meeting the audience wherever they are, and so knowing that you can't just plop, what I've created into a different context. It may not translate. In terms of a specific example, I don't have one for you offhand, but I do think this would be a really interesting avenue to pursue. So if anyone in the audience does have an example in a different language, please reach out.
Great, thank you. And then Shayna, Costas posed a question about how in order to bring together 3D data sets, mapping, modeling, all of these things, to really look at the system, you need a glue investment or some element that brings the intersection of all of these elements together. Do you have any thoughts on who makes that investment? And I think it actually dovetails with Tristan's question about examples that you might have. And so I think you can probably attack both questions with some of the examples of who you've worked with and how you bring these different disciplines together.
Yeah, and that's a good point, because this definitely is multidisciplinary, and it really is impactful when you can bring and combine disparate data sets and information from other places. So with the type of visualizations that I showed you, it would have been really interesting to overlay public health or population data on top of the impacts of some of these events. So in terms of the investment, I think that it can come from different groups, whether they're international groups, whether it's NGOs in the region. We are actually working on a pilot project with Guatemala City, and some of the funding is coming from NASA Disaster Applications group within NASA Science Mission Directorate. So, again, because it's R&D, it's not going to be operational yet. Eventually, it would probably need to be funded by a more operational agency, more of an emergency management type group. We've talked to cities who have, large cities often have budgets for this type of planning. Even private sector construction and insurance companies are very interested in protecting their investments. So I think having a consortium of groups who are interested in funding these type of visualizations would be key, especially early stage planning for major developments. Being able to understand what the risk impacts are could be very useful.
Excellent. Thank you, Shayna. And Emma, I actually have a question for you. You're part of this risk-informed early action partnership, and you were talking about what could have been done in the instances of both Kenneth and Adai, but also this idea of some of the dissonance between funding and even humanitarian response to like well-known events and then these invisible events. Is there a linkage between what the REAP activity is trying to do and some of the attention that is needed for these invisible events? And if yes, how so?
Great, thanks, Shanna. I think one of the first things to note in terms of what could have been done for Ida and Kenneth is that a lot of organizations are actually doing those things or starting to do things. So organizations that are members of REAP, like IFRC, many of the UN agencies, CSO networks like START Network, and a lot of governments, including ones in Mozambique, and in particular in Asia Pacific region, is as usual a real leader on this. They are making moves towards more anticipatory systems and using forecast-based action or forecast-based financing, depending on the organization. So it is happening, and the reason that REAP was established was because it's not happening at the scale that will provide a proper response to or a proper challenge to the climate crisis. So that's why within REAP, we want to try and bring the right section of actors together to not just be looking at that 10-day forecast. Where are the other opportunities leading up to it? Because we're facing, I know everybody's sick of the word unprecedented, but we are facing unprecedented crises and disaster as it relates because of climate change. And we cannot solve these issues in silos. We can't even solve one hazard such as that, such as the cyclone in silos. So we really need to come together at a really, really big scale. And just in terms of the communication of that, I think there was a really interesting point in the chat. Hopefully I pronounced your name right, from Chi Hui Voon, which was around COVID as an opportunity, because one of the absolute key points, apart from the financing, which really needs to be substantially scaled up, but also existing financing needs to be adapted to be more anticipatory. One of the key things that will turn early warning into early action and preventative action is around the communication of risk. And I think the COVID crisis, which we hope is somewhat coming to an end now with the vaccine news, there's a great opportunity globally, nationally, sub-nationally, and a community level to reflect on how we communicate about risk to public, to decision makers, from decision makers back to the public. There's a lot of lessons learned there, and there's a real chance to learn in terms of how we go about communicating the unparalleled range and severity of risks that we're now facing.
That's excellent. I mean, I think it also just really complements this idea of, I think that we're all talking about more and more is looking to the past or even the present to be better as we move forward into the future. And so maybe because we are reaching the top of the hour, I'll ask maybe for one brief comment from each of you on what you think the future holds. We'll start with Yolanda, then go to Emma, and then Shayna, and then we'll wrap up. So Yolanda, any thoughts on the future of this topic that we're discussing?
Yeah, I mean, I think we've really been focused so much on these low probability, rare extreme events. But today, I hope that we've made some steps towards moving the conversation away from the focus on the hazard itself and really towards consequences relative to response capacity and towards our agency to enact change. And really, like Sheena was showing in her powerful visualizations, we can really make this conversation of risk human-centric, tailored to the individual, like I said earlier, meeting them where they are to enable insight and motivate action.
Excellent, thank you. Emma?
I think, unfortunately, the future for this planet is that the animals are taking over the zoo, and we just need to be prepared for that. And I think a bit about this joke that my godson tells me over and over and over again, which is, where does a polar bear sit in your sitting room? And the answer is anywhere he wants. And that's the situation we're in now. So we need to look, like Yolanda said, start looking to the past to understand the impact for the future, because there's not that much that's unknown. Nothing is entirely unknown, and we have the knowledge and also a huge responsibility, particularly in Western countries who are causing much of the climate crisis. We have a huge responsibility to act better, act earlier with the information and the resources that we have. So I hope to see that happening.
Excellent, thank you. And Shayna, over to you.
Yeah, absolutely. I think that, we have the responsibility and the tools to be able to put together the information and synthesize this data in a way that we can really be better prepared and help um, make it more equitable. So it's not just the rich cities who get to have the visualizations, but, making these tools available for everyone. And if you can imagine in the year 2000, just 20 years ago, we didn't have these devices. We had the chunky little phones, but now with smartphones, think about the way that information is shared, how people have access to information, across the world. And that's, we're just at the tip of the iceberg with these type of immersive visualization technologies. You can imagine a day where we'll actually have heads up displays in our vehicles on the windscreen to be able to, see information as we arrive somewhere about these events. And so we're just taking the baby steps today. So hopefully I'll leave you with some inspiration and some hope to infuse technology into your programs, because there's a lot of exciting things on the horizon that will make a big impact and help us.
Excellent. Well, thank you so much for your perspectives. I've thoroughly enjoyed today's session. I hope all of our participants have as well. Questions are still coming in, but we've unfortunately reached the top of the hour. So please do feel free to reach out to us directly if you have any questions. But with that, I'll close the session. Thanks so much to everyone. Bye-bye.